Section 5.3, Angle Bisectors of Triangles. So our goal in this section is to use angle bisectors to find distance relationships and solve problems. To review, an angle bisector divides an angle into two congruent angles. Such that this angle and that angle are congruent. So we were to label this angle ABC and have a D on there. We would say that angle ABD is congruent to angle CCD. We've done all this already. What is new is the distance from a point to a line. We mentioned this in chapter 3 that a distance is on a straight line and perpendicular. That's what we need to know. So it's in a straight line along the perpendicular. So if we were trying to find how far is D from BC on this, we need to find that perpendicular and say this point is E. DE is the distance that D is from BC. It has to be on the perpendicular. If it's not perpendicular, then it is not a distance. All right, the angle bisector theorem. It reads, a point on the angle bisector is equidistant to the sides of the angle. So we have here an angle with the angle bisector already drawn, and we say that if the ray AD bisects angle ABC, then D is equidistant to the sides. So we say BD is congruent to CD. So a point on angle bisector is equidistant to the sides of the angle. The converse of this theorem says that if a point is equidistant to the sides of an angle, then it's on the angle bisector. So we will say that if JK is congruent to LK, but it's not enough just to say they're congruent because one could be at a different angle than the other, so we also have to say that they are perpendicular. So, and JK is perpendicular to JI, and KL is perpendicular to Li. Then, if they're both are perpendicular and congruent, then we say IK is the angle bisector of angle JIL. An example, find the measure of angle MNP and MNO. you really want to look at it and say, oh, angle bisector, move on, whatnot. But you really need to look at these diagrams closely because some of these give you information that one, you don't need, or two, is false for solving. So we look at it and say, okay, these are both 18, so they're equidistant, and check, they're both right angles, so we know that PM and PO are actually equidistant, which means PN, or NP, is the angle bisector, meaning this angle and that angle are congruent. So the measure of angle MNP is also 54 degrees. To find MNO, we're just going to take 54 times 2 and get 108 degrees. There are some problems we're going to see like this. For what value of x does t lie on the bisector of angle R? Again, in order for it to be on the angle bisector, it has to be, both have to be perpendicular. Check, we have that. And that means these have to be congruent. So it's just a matter of saying 3x minus 6 equals x plus 8. And solve, subtract x from both sides, add 6 to both sides, and we get x equals 7. And that's it. These don't necessarily have to be complicated. Alright. Next is the concurrency of angle bisectors of a triangle theorem. The concurrency of angle bisectors is called the incenter, so you could call this the incenter theorem if you wanted. So the incenter is the point of concurrency. On this diagram, it is point A. So what we did is all of these light purple lines you see here are the angle bisectors. And they meet at the point of concurrency, the incenter, point A. The incenter is the center of the circle that fits inside the triangle. So this time, we are drawing the circle centered at A, and we are going out to the point, and you can see that it goes through all 3 points, but the circle is inside the triangle. That's how I can remember incenter versus circumcenter. Incenter circle is inside triangle, and the other one, the triangle, is on the circumference of it. So, what does this mean? Just like before, the distance from the center to the circumference is the same. So, AX, AY, AZ are all congruent. In the diagram, A is the incenter of triangle UVW. So same diagram. Find YA. I do not have any information directly attached to YA, but I know that these 3 segments are equal, so we know that YA equals XA. We sound like a bunch of Canadians, eh? How can we solve for AX? We have a right triangle here. In order to solve a right triangle, we can use the Pythagorean theorem. So the short side we call side A, the other leg B, and of course the side always opposite of the right angle is the hypotenuse. So we will say that AX squared plus 12 squared equals 13 squared, and solve. So we get AX squared plus 144 equals 169. subtract 144 from both sides, we get ax squared equals 25. Square root both sides to cancel out the square, and we get that ax equals 5. And we knew that ax is also equal to ya, so we will say that 5 equals ya. A chunk of the time when you're solving with in-center, you are going to be using Pythagorean theorem. Almost every single time.